G'day all. This is experiment number 2 for the online group, which is the height to which a ball bounces after it's dropped from 1 metre. Now, I used the word experiment there, and our first one really was an experiment where we were changing one variable, which was the area of the parachute or the mass that we were hanging from the parachute or the kind of cardboard we made the helicopter out of. We were changing one variable in a consistent way and seeing how another variable related to it. This one's not really an experiment, it's more of an exploration because we have a range of different balls that we're going to use and they have a number of different characteristics. They have different sizes, different materials, different levels of inflation. Some are full of air, some are full of rubber, and so on. So there's not really one variable we're changing consistently. What we're actually doing is just exploring a space. So we're going to use those different experiences to try and make some generalizations about what we know. So have some predictions first. In fact, I'd suggest make a table of the different kinds of ball that you use. Now, I'm going to use about 5 or 6 different kinds. You probably don't have access to that many, but if you borrow them from kids and friends and so on and look around the house, you can probably find at least 3 or 4 different ones at home. Create a table with the different kinds of ball that you've got, and then predict which will bounce the highest and which will bounce the lowest, like rank them in order of bounce height. And then test your prediction. We're doing a sequence here called predict, observe, explain. So predict what's going to happen, then do the experiment and observe it, and then explain why your prediction was supported by the evidence or why it wasn't supported by the evidence. So here's one I prepared earlier. So I've got a column for the type of ball. So in this case, I'm going to use a soccer ball, a netball ball. Is that redundant? I've got a Mickey Mouse ball from Disneyland, branded from Disneyland, and a number of others, and a Super Ball, the really high bouncy rubber one, and a few other different ones as well. So you'll have that, you'll have the kinds of ball that you've got, and again, remember we're not doing an experiment, we're doing an exploration, so the order doesn't really matter. You just want to get a sense of them. Now, I think that the Super Ball is going to bounce the highest, so I'm going to rank it as 1. I think probably the netball is going to rank 2nd highest, the Mickey Mouse ball 3rd, and the soccer ball 4th. Now, I probably should also have a key here, which says 1 equals highest bounce, because otherwise we won't know whether big number means high bounce or big number means low bounce. So for me, I've ranked it from the number 1 highest bouncing downward. And then we do the experiment, we do the observations. So you just write what you observed. So you can say, this was actually number 1. And you should say something like 65 centimetres. So you talk about how high it bounced. This will mean more once we actually show you the experiment or the observations. And then you explain why you think that one bounced higher than you had predicted. Why was your explanation not supported by the evidence? Why was it wrong? Why did the evidence say something different to what your explanation did? And you can think about how you could improve the experiment to make sure that you're confident in the results you've got. Okay, what we've got here is not a model of the planets in the solar system, but it is a selection of balls that we will use in this experiment. So you can see that it goes, in this case, from larger to smaller. So I mentioned before enlisting your child, and I've enlisted my child, who is Cassie, who is a physics teacher, who's going to help me with this experiment. So basically we're dropping the ball. It's easiest to measure from the top of the ball rather than the centre of the ball to be accurate. So we're going to measure from the top of the ball to where the top of the ball bounces to. And Cassie's got down there low because otherwise you have errors if you're looking at from the top rather than from the side in measuring. So she's just going to try and tell us how high the ball went on the first bounce. Ready?
Yeah, I wasn't expecting it to go that low, so another go?
Yep, okay, so put that there as a marker. We do one more?
Yep. 57 centimetres.
Okay, so 57 we could write on the board for the soccer ball. All right, let's try the netball or volleyball. I'm not sure which. No, netball, it says it on it. Okay, so is it going to bounce higher or lower? What's your prediction say? Let's see.
lot higher, so we're about here.
Second trial.
76.
Okay, 76 versus 56, so that's or 57. That's quite a bit higher. Okay. Never let it be said this is a Mickey Mouse science experiment. We have a Mickey Mouse ball here though. So, ready? Prediction again. What do you reckon? Higher, lower? Oh,
Okay,
yeah.
maybe one more.
Yeah, second bounce seemed to be higher, didn't it?
That was my fault. One more.
Oh, experimenter.
About there.
So that is about
81.
81. So only a little bit bigger than the neck, about 5 centimetres bigger than the neck. Okay. Let the other lady stretch for a minute. Okay, tennis ball.
$58.
58, okay, so pretty close to the soccer ball. This guy which just says high bounce ball. I don't know if you can see it on the video, but it says high bounce ball. So
Handball.
if it's as good as advertised, then it will actually go higher than any of the others. I don't know, let's see. What's your prediction? Here we go.
We're physics teachers, not sports teachers. There. 75 centimeters.
75, so it wasn't the highest. And finally the Super Bowl, the little tiny guy. My prediction was that this would be #1 highest bounce. We'll see whether I'm supported or not. That was a bit of a shaky trial because it hit the ladder, the ruler.
74 centimeters.
Okay, that's 74. So it wasn't the highest. My prediction wasn't supported by the evidence. How about yours? Now you should write down your observations for each of those. It'll take you a bit longer to do the experiment than it took us because you'll need to write between each step. And then once you've got all of your data, then go to the explanation column and explain why what you had predicted, or why you think what you had predicted wasn't supported by the evidence. Okay, one of the things that you might have observed when we did the experiment was that some trials we just rejected because we dropped the ball and it hit Cassie's hand or it hit the ruler and it wasn't a sensible trial. So those data I wouldn't include at all, I would just reject. But to get a really accurate result, because there is some judgment involved and because any measurement has some judgment involved, I would do at least 3 trials for each of the balls and then take an average of the results. So basically we would take at least 3 trials. You could take 5 if you wanted to be super precise, but we'll try at least 3. And I'm going to pretend that our trials were very accurate. This is probably, so let's say we found a 57 first time. Let's say second measurement we got a 55, so it's a little different. Third measurement we got a 56. Now I'm going to average those up to find the answer. And it makes sense to think about, it's going to be somewhere in the mid-50s, the answer. So if you do the maths and you discover that it's 150, you've probably done something wrong. If you discover that it's 3, you've probably done something wrong. It should be somewhere in the mid-50s. Does that make sense? So I'll add the 3 numbers up. I would use a calculator for this kind of thing. In the olden days, I guess we would use an abacus or our brain. And that is 168. I have to admit I did actually cheat and use a calculator in between, or give myself a bit of extra time. So 168, and then divided by 3, that is going to definitely require a calculator. 168 divided by 3 is equal to 56. And so that makes sense. It's in the right ballpark. And if you look at it, 56 is like the middle, and one's bigger and one's smaller. So 56 is a sensible answer. So I will add my average. I haven't left enough room. Let me rejig my table slightly. It's not an equal sign because those things aren't equal to it, but it gives 56 centimetres as a more accurate answer than if we'd just done one experiment. we can actually improve the accuracy of our experiment. You could think about other ways to improve it as well. Things that we did included making sure that we measured from the top of the ball to the top of the ball because it was easier to see, getting Cassie to crouch down so that she was on the right angle, because to me from on high it looked as though it bounced lower than she actually measured it at. So having a second person is really helpful. Can you think of other things that would have improved your accuracy?